A fossil fuel company recently went to court in Sydney over net zero claims. But the most revealing part wasn't the offsets they used, it was what they completely left out. This video is about a loophole large enough to sail an LNG tanker through, calling fossil methane net zero by intentionally excluding the emissions that matter most. It's a trick that relies on specific phrases designed to make you stop asking questions. Phrases like clean natural gas. If you've been following energy news or actually just any kind of news listening to politicians recently, you've probably heard that phrase thrown around a lot.
Those big windmills are so pathetic and so bad, so expensive to operate.
Many, many times more expensive than clean natural gas.
Sounds nice, doesn't it? Natural, clean. But as an engineer, I find this phrase highly problematic. Let's start with natural. It wasn't named that because it's good for nature or as wholesome as a forest glade. Historically, the term was just used to distinguish it from town gas, which is a synthetic, toxic gas made from coal that used to be piped into cities for streetlights. So natural really just means we didn't have to manufacture this from coal ourselves. It's exactly as natural as crude oil or anthracite coal. And then there's the word clean. Seriously, what is that word doing next to a fossil fuel? It's intended to imply that it's cleaner than coal, which maybe sounds like it obviously is, but actually even that claim is getting less and less clear with every study that digs into the topic recently, particularly now that we're monitoring real leakage from the supply chain. We'll talk more on that later. So now let's do the opposite of what the clean natural gas marketing wants us to do. Let's get specific about emissions and expose the accounting tricks. I'm Rosie Barnes. Welcome to Engineering with Rosie. Now, I'm not sure if you remember, but a few years ago, Santos were making a lot of noise about their net zero LNG project. They also made claims about zero emission hydrogen as part of their positioning of themselves as a clean fuels company with a clear and credible pathway to net zero emissions by 2040. And those claims landed the company in court in Sydney earlier this year, with Canadian chemical engineer and vocal hydrogen critic Paul Martin called in as an expert witness as part of that case. I met up with Paul while he was in Sydney for the case to ask him what the deal was. What's the case?
Sure. So the Australasian Centre for Corporate Responsibility is suing Santos for claims that they made regarding their targets for GHG emission mitigation from their operations by 2040. And I'm here to support the ACCR in their evaluation of Santos's claims related to using hydrogen as part of that strategy. So they were going to build a facility in Moomba where they were going to build a blue hydrogen project.
Blue hydrogen means hydrogen produced from fossil gas with the CO2 emissions captured and stored underground, which, by the way, never occurs with absolutely no emissions at all. There's always some leakage. And then after they made the hydrogen, Santos would have had to have somewhere to sell their clean, not really clean, hydrogen. They said they would blend it into the gas network. The ACCR claimed that's not plausible, and they brought Paul out here to talk about why not. Paul's been on Engineering with Rosemary before, by the way, actually talking about that exact topic if you want to watch. A key part of the argument is about how Santos planned to use hydrogen as part of their clear and credible pathway to net zero emissions by 2040.
At the time, they were making big noises about this, and this was the way that they were going to achieve their results. 2.5 million tons a year of CO2 emission mitigation that was going to come from hydrogen. And of course, that's only possible if it's actually possible to do so. And that's the nature of the argument. Is it possible? Would it have been possible to do that if that was executed? And what would that have involved? Would it be a simple matter of just dumping it into hydrogen into the natural gas network? Or would you have to build new pipelines?
So to summarise, if you're going to greenwash, you have to do it in a plausible way.
Not only is it possible, does it fall within the limits of thermodynamics or physics, but also is it sensible and economic and practical? Mm. And if the answer is yes, you could do it if you had all the money in the world, it was not reasonable to assume that.
So basically, the case is trying to show that Santos's net zero claims were not made in good faith, partly because they would have or should have known that there was no way that their zero emissions hydrogen was ever going to happen for a variety of technical and economic reasons. So that's interesting, but I've got to say it's actually not what I thought that this case was going to be about. I had seen Santos's net zero LNG claims in the past, and I just assumed that they involved the standard playbook. Emit as usual, but buy a mountain of cheap offsets to cancel it all out on paper. And actually they were planning to do a little bit of that in addition. But that just makes the hydrogen part of the plan even more confusing. See, the offsets that they were planning to buy are incredibly cheap. So why would you even bother to plan a more expensive, more complex blue hydrogen project? It defies economic logic, which just adds more legitimacy to the question, was the hydrogen ever a serious plan, or was it just a shiny green distraction to give investors something else to focus on other than to question the legitimacy of the net zero plan or calling Santos a clean energy company? And speaking of that plan, here's the other thing that surprised me. When I saw the net zero LNG, I assumed that meant that they would offset the entire climate impact, extracting, transporting, and burning the gas. But they weren't even proposing to do that. If you were to buy that net zero LNG from Santos, it's only net zero until the moment that you use it, when you burn it. When you burn it, those emissions are all on you. From the customer's perspective, there is absolutely no difference between the zero emissionsness of this gas compared to any other fossil gas.
The idea is that they will offset or bury CO2 or use whatever strategy that they need to in order to make the production and liquefaction and transport emissions go away. And when that's done, the emissions that you get when you burn their product are not their problem, they're your problem. So it's not net zero in any meaningful way. So my concern with the idea of fossil fuels being net zero is that they're always only talking about production and transport, and they're never talking about end consumption. And with the end consumption being the booby prize that you get, and that will never be net zero, it really is just a greenwash.
Quick note before we get into scopes and methane leakage, if you want to support this kind of forensic, clip-heavy deep dive, YouTube members and Patreons are what make it possible. Members get early access to videos, and I also share ideas and sometimes research on the members-only Discord channel. And I often get great tips and feedback from members there. The links are in the description. In some ways, there's a kind of consistency to Santos ignoring emissions from combustion because companies' net zero targets are normally based on their Scope 1 and 2 emissions. Scope 1 is direct emissions from a company's own operations, such as emissions from on-site gas combustion or fuel combustion in company-owned facilities or vehicles. Scope 2 is indirect emissions from the energy the company purchases, mostly emissions from electricity used to power facilities. They leave out Scope 3, which are emissions resulting from the use of a company's products by customers, because once it's sold, you don't really know or control what customers do with it. For instance, a semiconductor manufacturer produces chips that their customers might use in vastly different ways. A chip could be used in energy-intensive applications like crypto mining, or in energy-saving applications like solar inverters. So that makes Scope 3 emissions harder to calculate and manage. And so that makes sense for something like a chip. But fossil methane or coal, you know what your customer's going to do with it. Burn it. Emissions from that burning alone make up anywhere from 34 to 80% of LNG's life cycle total, depending on how you measure the climate impact. That huge range exists because recent research has discovered that upstream methane leakage, before the gas even gets on a ship, is far higher than expected, contributing up to 38% of the total footprint. Remember, that leakage enters the atmosphere as methane, which has more than 80 times the warming potential of the CO2 emitted from burning it. This massive upstream leakage is typically not accounted for in net zero plans that focus only on production operations. So we're left with maybe 10 to 20% of emissions reductions in Santos's so-called net zero LNG. It's incredibly misleading to claim a fossil fuel is net zero when the vast majority, like 80 or 90% of the emissions are ignored. And even that minuscule proportion that is included is problematic because it relies on offsets.
offsets themselves are a sketchy business, because often what you're buying when you buy an offset is someone standing beside a forest with a chainsaw saying, give me money or I'll cut the trees down.
Carbon offsets have become a popular way for companies like Santos to claim progress towards net zero goals, but offsets are often riddled with issues that make their actual climate impact questionable at best. Study after study has brought up issues of exaggerated benefits and lack of permanence across the offset market. I've covered this in a fair bit of depth in a previous video if you want to take a look. Offsets tied to projects like LNG production rely on the same problematic mechanisms. For example, a total shipment of carbon-neutral natural gas had its emissions offset by a scrub clearing project that aimed to prevent deforestation by stopping wildfires. The actual emissions benefit of these kinds of projects are basically impossible to verify, making it hard to ensure the claimed reductions are real or lasting. Okay, so it's clear that net zero LNG, of the kind Santos promoted, was never going to be a real scalable solution. It relies too heavily on offsets rather than stopping emissions at the source. But this brings me back to a controversial point that I made in my previous video on long-duration energy storage. I argued that it's actually better to target the 85 to 98% of grid decarbonisation that we can achieve cheaply today, and to continue using methane gas for that last incredibly difficult sliver of peak demand. So what does that mean for LNG emissions? Naturally, plenty of you took to the comments and LinkedIn to remind me using methane doesn't have to mean using fossil fuels. You pointed out that biomethane and other zero emissions options exist. So let's see if those options can actually deliver real net zero where fossil LNG fails. First, let's look at biomethane. Think of this as recycled methane. It starts with organic waste, agricultural residue, food scraps, or sewage. We put that waste into a tank without oxygen, called an anaerobic digester, where bacteria break it down to produce biogas. For example, I recently visited a piggery that does exactly this. Instead of letting the pig manure sit in open ponds releasing methane straight into the sky, they cover the ponds to capture gas. To get grid quality biomethane, you just take that raw biogas and upgrade it by scrubbing out the CO2 and impurities. The result is chemically identical to natural gas, but because the carbon in it was recently absorbed from the atmosphere by plants, which in this case the pigs then ate, burning it is considered carbon neutral. Then there's E-Methane, or synthetic methane. This is the high-tech route. You take green hydrogen, made by splitting water with renewable electricity, and combine it with captured CO2 in a reactor to create methane. In theory, this creates a closed loop. But as Paul Martin pointed out when I shared the draft script for this video with him, this process is an exergy destroyer on steroids. Think about it. You're taking high-value renewable electricity, using it to make hydrogen, then probably paying a whole lot for captured CO2, and then spending even more energy to turn it into methane, only to burn it back into CO2 and water. You're essentially grinding up useful energy just to make heat, losing most of the value in the process. And that brings us to cost. Because of that energy intensity, e-methane is staggeringly expensive, currently estimated at about 4 to 15 times the price of fossil methane. There aren't a lot of commercial projects yet to give a really accurate price there. Biomethane is a lot cheaper, but it still typically costs more than fossil gas, though it is becoming competitive in regions with carbon taxes. But can we actually make enough of it? Well, a viewer got in touch with me on LinkedIn and pointed out that in Denmark, roughly half the gas grid is already biomethane. And that's true. In 2023, the share of biomethane in the Danish gas grid reached nearly 40%, and they aim to be 100% green gas by 2030. Globally, the potential is also significant. The IEA estimates that sustainable biogas and biomethane could technically cover about 20 to 25% of today's global natural gas demand. That sounds low if you're trying to replace all gas, but if we look back to the argument I made in the long-duration energy storage video, we only need to keep methane for that last 2 to 15% of the electricity grid that's too expensive to run on batteries. For that specific narrow purpose, sustainable biomethane is probably scalable enough to do the job. So yes, we could, in theory, have a net zero gas grid, but we have to be realistic. It may not be cheap and it definitely won't be infinite. That means saving it for the hard applications, not just replacing like for like on today's grid. And we also need to remember that regardless of where the methane comes from, whether it's a piggery or a lab, You still have to be obsessive about leakage. If your clean green methane leaked before you burn it, it warms the planet more than 80 times faster than CO2, exactly the same as the fossil version. And this is where the net zero dream really hits the wall. Leakage. Even if you synthesize the perfect green molecule, the physics of keeping it contained are a nightmare. When we look at the full life cycle of LNG, the emissions profile is stubborn. Research from the IEA and others shows that while the liquefaction process, supercooling gas to negative 162 degrees Celsius, is energy hungry, it accounts for about 8 to 10% of emissions. The real silent killer is methane slip. Methane leaks at every stage, from the wellhead to the pipeline to the ship's engine, where unburnt methane slips out of the exhaust right down to the power plant. Because methane is so potent, even a leakage rate of just 3% across the supply chain can make gas as bad for the climate as coal. So unless we have a leak-proof supply chain, which doesn't exist yet, net zero methane remains a fantasy no matter what its source. So whatever happened in that legal battle that I talked to Paul about? The hearings actually wrapped up in late 2024, but in the final days of 2025, when I'm recording this, we're still waiting on a final public judgment regarding the liability and penalties. The wheels of justice turn slowly, even when the climate is changing fast. However, Santos hasn't exactly been keeping their heads down. In their 2024 Climate Transition Action Plan, they actually kept their 2040 net zero Scope 1 target, but they quietly moved their Scope 2 net zero target back by a decade, from 2040 to 2050. Their excuse? The electricity grid isn't decarbonising fast enough. They've also started adding a lot more aspirational language, heavily qualifying their targets on the condition that technologies like carbon capture and storage actually work and are commercially viable. And speaking of things that haven't been working, in August 2025, it was revealed that Santos had allegedly been covering up a methane leak at their Darwin LNG facility for nearly 20 years. Documents obtained by the Environment Centre Northern Territory suggest the facility had been leaking since 2006. Estimates of emissions from the leak have varied, ranging up to the equivalent of millions of tonnes of carbon dioxide. And the regulators knew about it, but just didn't require it to be repaired. It's such a stark reminder that while companies debate the finer points of net zero definitions in court, actual gas is often just leaking out into the sky because it's apparently too expensive to bother fixing that. Thanks for watching Engineering with Rosie. Don't forget you can join us on Patreon or become a YouTube member. You can also help the channel by liking, commenting, sharing this video. I'll see you in the next one.